In a previous video, we looked at the by hand solutions to the line integral shown on the screen here, evaluating along the parabola segment back along the line segment to 0, 0, and we're integrating the function x plus the square root of y. And we showed in a previous video how to split the line integral along two curves, C1 union C2, where C1 and C2 were the parabola and the line respectively. And we did all the integrals by hand to get a number for the answer. Okay, and in this example we'll show how to just check your answers in Mathematica using some integrals. And what I have on the screen here is just the definition of the function that you're seeing. Okay, I've got the two curves parameterized. One was the parabola, C1 is the parabola, and C2 is the line segment. And then I pasted those curves, C1 and C2, onto the surface because that's what we are doing with doing this line integral. You're finding the function values over the curve, and those function values are z values, and so R1 and R2 show the curves that you could see there is the curves in the xy plane, as you can see on the right side of the screen, but that function x plus square root of y makes it so that some of the z values near 0, 0 are smaller than the z values as you get closer out there to the point 1, 1. Okay, so here's the problem set up, and we needed to find the line integrals. And along the first curve, if you go to Palette's Writing Assistant, you can select some of the integrals. And along the first curve, we needed to do the x values, which were t, plus the square root of t squared. Okay, and then multiplied by, let's do this, multiplied by the magnitude of the velocity. And the magnitude of the velocity for the parabola was 1 plus, square root of 1 plus 4 times t squared. Okay, there's the square root, close the parentheses. And let's put a parentheses around all of that so that we can separate it from the dt, and we needed to integrate from time 0 to time 1. Okay. And if you hit Shift Enter, okay, hopefully that was the answer you would get for the integral along the curve C1 here. Okay, so this is the C1 line integral. Okay, the second line integral we had to do was C2 line integral along the straight line. And again, we needed to do an integral, and it was an integral from time 0 to time 1. And I think x was equal to 1 minus t at that point, plus the square root of 1 minus t. Okay, and we needed to multiply all that, times the square root of 2, which was the magnitude of the velocity of your straight line. Okay, and then that was a t integral. Fill in the box here if I can highlight it. T, and then Shift Enter, 7 over 3 square root of 2. Okay, so adding those two results together, and you will get the answer, I believe. Okay, so this plus this number is the number, the pink number that you're looking for from the line integral. Okay, if you want to see what that is, you could do copy and paste this, Control V, put it in front, Shift Enter, And there is your answer. If you would like to see that as a decimal, put a n for numerical number around all of that integral, and you get your decimal. Okay? So concludes the figuring out what the number is for the line integral shown here in problem 13.2, 6.1, number 25.